know about the, yeah, when you do start the lab, if I'm not, ushering you in there, make sure you get the correct machine name here, otherwise you may be blowing away somebody else's work. In our lab here, it was mentioning that, Windows should be up and running on the system, and that's not the case on the machines at the moment. So I'd forgotten to bring in my Windows disk last time to, fix it up so that it actually booted. So you may just have a machine that doesn't really want to boot anything at all, and that's okay. Just go ahead and do what it says in the lab. But you might find something that's a little different from what the directions say. That will affect how things work though for you. Okay. All right, now 408C, those of you who have been to Bits and Bytes, first one of those is on Thursday, by the way. Our lab is basically right across the hall from where Bits and Bytes is. Bits and Bytes is room 405, we're in 408 in the GMCS building, 408C in particular. And very close to that is the Math Computer Science office. And if the door isn't already open, well, actually the door probably isn't supposed to ever really be open. The fire marshal wants all these doors shut all the time. I'm supposed to conduct my office hours behind a closed door, but that's not going to happen. So, first thing you do is knock on the lab there, because maybe there's people inside and you don't have to go bug anybody about getting in. But otherwise, you look for me if it's a Tuesday or Thursday, otherwise don't bother. And then you can go to, when the Math Computer Science office is open, you can go in there and hopefully the guy will, without too much grumbling, come and let you into the room for you. Unless some of our lab instructors are already there. All right, so I'm going to see if I can get the key. Okay. All right, so I think that's just a general announcement about how the labs and stuff work. We're going to pick up and talk a little bit more about what's going on in Lab 1. Now, as we'll see a little bit later on, you're going to be setting up your own accounts, and I don't have that information available yet. So even if someone was going to do it today, it doesn't look like any groups are trying to start today, right? That's where we're at. By Thursday, I'll have all this information. Right now, you won't know what user identification number you're supposed to put in until I hand out, run-out accounts and things like that, and then we'll just mimic those numbers. Okay, so I didn't have enough time to get that done over the weekend, mostly because I have the mother of all colds here, so don't get too near me or try to shake my hand or anything, or I'm likely to infect you. All right, so we'll see how long my voice holds out under these interesting conditions here. All right, I think we stopped at around line 24 last time. Does that match what people kind of remember as where we've gotten here? I think we had tried most of this stuff before that, but we have looked at what happens when we actually boot the real Mint from the actual disk, which is what should happen this time around. Now, among the things that it had done when it was setting up the account here was to shrink your user partition, the partition that Windows was using to make room for our new operating system. And indeed, we wanted to shrink that quite drastically because we're not really going to use Windows at all. We want to have plenty of room for the things we are going to do here. So it did all that, and then it put in a new boot menu, which is GRUB, the Grand Unified Bootloader here. And as it did the installation, it noticed, hey, there was a Windows system that looked like a valid system. And so that's going to be one of the menus here, items here, would be to boot Windows if you want to do that. If we had other versions of Linux or pretty much any other operating system, GRUB would have noticed that as it was looking through all the partitions. And for everything that looked like it had a valid operating system on it, it will give you a menu item. Okay. So we have two main menu items here, one for Mint and another one for the Windows 7. Actually, it isn't completely sure which partition you're supposed to boot off of, so there's really actually two Windows 7 entries there. I think only one of the two of them works. You have to pick the right partition to go to, which is, well, actually I forget which one it is. And for Mint, on purpose, they put several menus there. The normal one that you would get if you're doing a standard boot, and then they have another one which brings you into a sub-menu where you can do lots of different things, boot in different ways, etc. Your Mint system. But the default is just bring it up normally, and if we do nothing, even if there's a power failure when the machine comes back on, it'll go by default into the regular Mint menu here. Okay. Oh, yeah, just one other thing I wanted to mention. If you want to make things go a bit faster here, and you happen to have a USB stick around, you may want to put the ISO image onto that USB stick. Right? So if you go to the Mint page, Linux Mint.com or whatever it's called there, or just download Linux Mint, put that into Google. It'll take you to the right place. It'll tell you where to get an image that you can put onto a USB stick and make it a bootable stick. That will go quite a bit faster than pulling things off of a DVD-ROM, because USB is, flash memory is certainly faster than spinning DVD. Now you need to make sure you get Mint 17.2, right, with the Mate desktop, and very important, 64-bit. Right? So they have 32-bit and 64-bit. Things are going to break if we don't have the 64-bit one. Right? So the DVDs that I've got sitting in the room are indeed exactly this. But you can use your own as long as you make it match. There's other desktops you can get like Cinnamon and whatever, but for things to work the way we expect them to, you want to install Mate on there instead. And make sure you get 17.2 rather than 17.1 or 17.3. And so feel free to do that in the next couple of days before you start the lab, and it'll save you several minutes. And then you can repurpose your USB drive to something else. Yeah.
What tool do we have on the Windows side to burn the Linux ISO to the flash drive?
Say that one more time.
What tool do we have on the Windows side to burn the ISO to the flash drive?
I don't recall how you would do that on a Windows thing, but if you just Google the download or whatever, Mint has very specific directions about what to do if you want to do it from a Linux system, if you want to do it from Windows, if you want to do it from a Macintosh, and so on. So I don't know that off the top of my head. I have done it before, but it's just reading what they tell you to do on the site. So yeah, you have to look at it that way. It's a fairly simple procedure. So I doubt that you'll have to download any new Windows software or something to do it. It's probably just going to work without much trouble. Okay, and especially if you're thinking of sometime putting this on your own laptop or whatever, then having that little USB stick saves you time twice rather than just once. All right, so within your groups, you might want to designate someone to the USB boy here and create a stick for you to use. And you can fall back on the 2 discs. I only got 2 of them, 2 DVDs in the room right now. So for some awful reason, 3 groups are trying to do it at the same time. Somebody's going to have to wait 30 or 40 minutes until the first part of the lab goes through. Once you get to this stage here where you're ready to reboot, you don't need the DVD anymore. You can pass it along to somebody else. So I'm assuming we're not going to run into that problem, but that's another good reason to have the USB stick, because you've got your own ticket freedom there without having to rely on who's already read the discs. Now, when you do get done, put them back on top of the machine in your corner there, which, as I say, I think is Aragorn again, so that people can find them after you guys have finished. Don't leave them hidden inside your DVD drive, because that just makes it into an Easter egg hunt for everybody else. All right. Now, when things sort of go wrong, there are other items you can pick from the grub menu here. One of them is called recovery mode here. And if your machine isn't booting up the way you want because something is strange with your graphics card, or maybe you've changed your disk drives recently and it isn't quite doing that right, you can tell it to try to go into recovery mode, and then it'll presume you have a really, really simple graphics terminal. Just use plain old VGA graphics rather than the fancy graphics that come with most video cards and stuff today. It'll make sure it doesn't try to resume from the swap area of a previous boot. Maybe that's the thing that got messed up. So it turns off lots and lots of features, and very often you'll then be able to boot even if the normal boot wasn't working correctly. Okay? In general, you want to be able to sort of get back up and fix whatever the problems are. And worst comes to worst, if even that doesn't work, well, then you put in the DVD again and do Linux Mint, mount some drives, and poke around and try to fix things from that. And again, that's among the things we simulate in the course here, so you can see how to fix broken systems without having to just start all over and reinstall things again. Okay. All right, so with any luck, you'll just be able to boot up normally, and it'll work out fine. And you log on then as this one Lucy user that we had, right, with loser, and we have that goofy testing password that you would put in. Right? So that gets you into the machine here, and you'll get a graphical interface and stuff that comes up from that. Okay? And down where the start menu used to be in Windows, there is a little green icon here that'll bring up options for you. Right, so there's a little roll-up window that comes up there. You can choose a terminal there, a little black thing that looks like a terminal. And now you have a command line interface to be able to work with, just like you do on, say, Rohan. Okay. All right, so there's lots of stuff that can be happening that you don't actually see. Each night we rebuild a database and looking at the names of every single file on the system so that you can instantaneously find where these things are. And on many systems here, we have man pages that are unformatted to begin with. And so on some Unix systems, they then, once you've installed your system, go about trying to format each of those man pages. So you could have something that is slow for a while because it's doing all this, maintenance work, but eventually it'll speed up again. I don't think we have that issue with Linux Mint here, but it is something to keep in mind with other installations. All right, now assuming we've got you hooked up correctly to the Ethernet and stuff here to the back of your machine, the installer should have found an Ethernet card. Right? We saw at the very beginning of the installation, it wanted to happen to see if it really could get out to the rest of the universe so that you'll be able to do updates and whatever. And you weren't supposed to proceed unless there was a little checkbox there. Let's see, as of this exact moment, 7 of the 8 machines have got Ethernet cables plugged into them. Before I ran over here, I did get an 8th cable, but I haven't installed it, and I'll try to do that this afternoon so that all 8 machines will be ready to go. Okay. All right. So given that, we've noticed in the directions that we had earlier, we didn't try to tell it that, hey, this machine is named Bilbo or Gandalf or Gimli or whatever. That's something that a server that I've set up is going to assign for you. So what actually happens here with DHCP is that when you come up, basically you send a cry out for help, hey, this is my Ethernet address, does anybody know who I'm supposed to be? And one of the machines on the little network in there, Legolas, is the server for DHCP here, and it looks in its database and it says, okay, you were Ethernet card, blah, 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 right? There's 6 octets of numbers there. This is the name that you're supposed to be, right? And here's who your DNS server is, and that's Legolas, by the way. Plus we have a backup one of Rohan, or maybe it's Mongo. I forget which other one I had put in there. But it sets up all those things for you so that your network can work. Right? So you put out a broadcast cry to the whole world, does anybody know who I am? And in our case, Legolas should answer and tell you who you are. All right, so when your machine actually came up, it should identify itself as being whatever name it says on that little label now. The only way that sort of thing would change is if we, move Ethernet cards, and since these are attached to the motherboard, that's, probably not going to happen on these machines. Okay, all right. So that's how that piece of magic works. We'll get into that more later on in the course, but for right now, that's why these guys know who they are. All right. So here are the possible names that we have. Here, I've got 8 machines in the lab right now, and they're using those names. If we get a 9th machine, that one's probably going to be the Smeagol one. So you guys ought to pick something else from this list. As I recall, we have currently used Gimli and Aragorn and Gandalf are the folks who have chosen names, and Sam at this point. Right? So those names are currently taken. The other 4 are still up for grabs. If you have a favorite amongst your group, get it before somebody else does. Okay. All right. Now, the name doesn't really help you get anywhere. What's really important is the internet address that you have. So we can find who we are by using the ifconfig command, and that's the interface configuration summary about all of your different addresses here. One of them is a loopback address. If you go to 127.0.0.1, that just means come back to this same machine, whatever the name is. So you have an outgoing TCP stack here of things that are supposed to be delivered to the outside world, and an incoming stack. And when you go to 127.0.0.1, it just takes any such packet from the outgoing stack and puts it right back on the incoming stack. It really is the loop-back interface. Every machine has that, and every machine uses that exact address. All right. So Legolas itself is 10.0.0.1. And the 8 machines that you guys are going to be using are labeled 2 through 9. Right? And that should match. You find a little label on the hardware that you have there, which should say your machine name, and it should also say your address. So do a sanity check to make sure you've got what you expect to have at that point. And let me know about any problems, because that means something very strange has happened along the way. Okay. Now, if you don't get anything coming up, it could mean that Legolas is broken at the moment, or not answering requests, or turned off, or whatever. But as long as it's up and running, then everything should work out okay. All right. Now, we set things up. We answered the question before, so the root password perhaps has a really stupid name associated with it. And we don't want everybody to know the name of your root password, so we're supposed to have one. We argued about that earlier on in the labs while it was doing the install. All right. So the password command is the thing you can use to change your password. And if you just say plain old password, it'll change the password of whoever it was you logged in as, which would have been loser in this case. But you can say password and give it a username to change, and then it'll change that particular user's password. Now, needless to say, that only works if you're a root. You can't go on Rohan and change everybody else's password for them and just make a pain out of yourself. Right? But as root, you can change anybody's password you want. Okay, and for that matter, as we'll see, you can become anybody that you want. Now, we could go down to that little window again and find the terminal icon and click on it a second time to bring up 2 windows. But as soon as you've got one window open, if you do Shift Control A, you get another terminal window in there. So now you'll have 2 screens on there. And one of them you can be root in it, and the other one you can just be a normal user. Okay. All right, so that's the fastest way to get a new one, but it is possible to use the menu just like you did the very first time. All right, so we'll do an SU here, which is a switch user command, and you can, as root, switch user to anybody you want. Well, as anybody, I guess you can switch user to whoever you want as long as you know their passwords. But SU with nothing lifted here is going to switch you to root, assuming the system is willing to let you do that. And we're going to make changes to the security features as we go along, mostly in Lab 2. Okay. All right, if you're going to change your password here, they want to make sure that you haven't just shown up that someone left their terminal a while and someone sneaks in and changes their password. You need to know the old password before it'll let you put in a new password. Right? So you'd have to enter the old password and then pick whatever you have chosen for the new one. All right, and now that you have 2 windows open here, now it's time to check that things actually work. So among the things we'll do is we'll learn tricks in here how to avoid shooting yourself in the foot. You changed your password here and maybe you just unluckily mistyped it twice in a row and it accepted that. Right? But now if you just log off and come back later, you can't become root anymore because you don't know what the password is at that point. So while we have another terminal open, you can go to a different window and see that your password really does work over there. Okay, and then get back to where you have a normal password, and a normal account, and one super user account rather than two super user accounts. Now things are a little, depending on your operating system, when we do SUSE later on, you really do have to enter root's password to become root. On the Mint system, like on Ubuntu systems here, you entered your own password to become root rather than root's password. All right. Now, this is a good place where you can take a break. It's going to take a while to do these things, and some people may have to run off to classes and whatever. You're not really in the middle of anything at this point if you want to break at that stage. And I'll try to identify a few other ones as we go along as well. This is one of the longest labs that we're doing in the semester just to get things set up. Okay. Right, so now we want to get a bit of a better shell here, and we'll see how to do this. Now, we're going to install hundreds of different packages here, but I've just given you a script where all of that stuff happens, in the background by itself. But we want to, 1 or 2 or 3 times here, see how to do this kind of thing on your own. Okay? So I could have just put this in the script, but this gives me an opportunity to talk about it here in class and give you a little bit of experience about what happens when you do these things. All right. So if you just try to type TCSH to try to get that shell to come up, it tells you that it doesn't exist, and in many cases, if it's something that it recognizes, it'll tell you how to go about installing it. And so you could try to do this, and again, we're going to try to do this as a lowly user, and we'll find that doesn't work, right? Because this is going to be changing some databases on a system-wide basis here. And regular users aren't allowed to do that. You have to be root to be able to make major changes to the system, like install software packages. Right? So we want to watch that fail. And as a regular user, if you put sudo in front of it, that means that as root, go ahead and do this, and then it asks for a password, and then it would let you do it. But instead, we'll just go over to the window where we already have the rootly powers, right? The one with the # prompt, and do it there, and that one should work. Right? So look at the error messages, make sure you're used to seeing what those things look like, and then do it right to get that in. Okay. Now, it will attempt to do this and say, okay, I found that package. If you do this, then maybe I need to drag in some of these other libraries and stuff that we didn't need previously, but now we do. And it's going to take up this much more room on your disk, and then it'll ask you, do you really want to proceed to do that, right? And we say yes, and then it works. Okay. Now, when I give you a script to do this stuff, you don't want to have to sit there and keep saying yes over and over and over again. It is possible with aptitude to give it the -y option here, which says, just answer yes to all questions. As long as you're doing things that aren't completely dangerous, that generally works out just fine. And I debugged the script and tried it. It'll work fine for us in lab 2. Okay. All right, so now, if you type TCSH, it should be able to find this. At least in the window where you installed it. In the other one, it may not actually know about that. Okay, so I guess when I tried it, this did work for me. But the one thing we should talk about is a little bit about how your path works in Unix. Right? When you type something like ls, how does it find where an ls command is? Well, you've got a path thing which says, hey, look here first in this directory, see if you can find something called ls. And if that fails, look in the next directory that you've got listed in your path, see if it's there, and keep doing that until you find it. First one you find, that's the guy you're going to wind up executing. Now, TCSH is going in user bin TCSH or bin TCSH, or maybe it's really in both places. They put it in one spot and put soft link in the other one for it. Okay. So you think you should be able to just find that, whenever you want it, as soon as it's there. But we really don't want our shells, each time you type the ls command, to look in one directory, maybe not find it, then look in the next directory, maybe not find it, look in the next directory, not find it, until eventually it finds it. That's very, very inefficient. So what happens when you log on, or when you start up a shell, basically, it looks through all of those directories and makes a big, long hashed list of all the names that it finds. So that when you type ls, it goes into its hash table and says, aha, that's the guy I'm going to execute, just like that. But now, after you've logged on, if you slip in some new software there, that's not in the hash table just yet. So some of the installation things here can fix up the hash table of every login process that's around, so it does show up there. But that doesn't always happen, and we'll see some examples later on where it doesn't happen the way you would expect if we install our own software rather than using this fancy stuff. All right, now the thing for us right now is called Aptitude for our installations. There are other things that they use. Yum is one of the ones. RPM is one of the things that happens. So we'll see an entirely different way of doing this when we do SUSE. And each of you is going to create your own virtual machine with some other flavor of Unix. And who knows which version you're going to find on that. So they all have basically the same philosophy here, and it's to rationalize all these packages. So we have tens of thousands of different packages here, and they all work nicely together, which is very different from the Windows situation. The Microsoft people can sort of make their own stuff play nice together, but there's all sorts of other people designing software for Windows which need their own little libraries and so on. And if two different vendors pick the same name for a given library, well, you install one vendor's stuff and it puts this library in place on your Windows system. And then you install this other guy and it overwrites the first one, and now you've broken the first application. So they do a very good job of making sure that all these guys play nice and you have all the features that you actually need for each package. So when we tell it to install TCSH, the Aptitude program has its own little checklist here. Well, when it gets the package, there's a checklist inside which says, hey, you need this library and this library, this library, and this library in order to run this thing effectively. And it looks to see if those guys are installed. And if they're not, it's also going to download those extra libraries that you need and put them in. When you remove things, besides installing things, you can remove some things. If it finds a given library, something like that, that is now not used by any other package, it'll also generally uninstall that for you. So it depends on what utility you're using. There's an apt-get guy, which is not quite as nice as Aptitude. Aptitude will get rid of stuff that you no longer need. And if you need it again, it'll download it again someday when you're installing more software. But it keeps your system clean and consistent along the way. Okay. All right, so that's one way to do it. The main way we'll do it is through the command line interface. That works pretty much on all different systems. But they also have graphical user interfaces which do these things, and that's going to vary by vendor. So Mint is different from Ubuntu's, even though Mint is based on Ubuntu, and Ubuntu's is different from SUSE and so on down the line. Okay? So we'll try this thing. Basically, in the menu there's an option for Software Manager. And you can try to bring that up. Right? But that little menu, your desktop here, is controlled by a regular user, not by root. Right? And this Software Manager, of course, is going to do things like those installs up there. So it's not really going to let you run that unless you can prove that you're really used. Right? So it's going to ask for your user password for that to work. Right? And then it would let you do some things. All right, so you get a little interface up here, and there's a little search bar up in the upper right corner with a magnifying glass, to indicate searching there. And you can type in SSH and hit return, and it'll bring you a whole bunch of things. Any place where in the description or the name of the function, it happens to have those three characters, it would do that. So if there's a utility called asshat, then you'll probably find that in your list as well. Okay? But somewhere along the way, you'll get to this one here, the OpenSSH server, which for some reason isn't installed by default here. I guess not everybody needs that if they're not getting out on the internet. But we definitely want to install that guy so that we can get out to the rest of the world. That's the kind of thing that you had done on your Windows system when you needed to talk to Rohan. You needed PuTTY or OpenSSH to be able to get to these other places. Okay. Now, if we got a Macintosh or something like that, that's based on Berkeley Unix, and almost certainly the SSH package is installed by default on those, if I remember right when I put mine together. All right. Now, to go out to the rest of the world, what you need is the OpenSSH client here. Okay? And that one almost certainly is by default. You can double check, and if it's not, do it. But when you get to that one, probably you won't be given the option of installing, you'll be given the option of making it go away. So you can already do an SSH to the outside world with that. But incoming connections are not going to work unless we have a server running and listening at the proper port. All right, so we're going to tell it to install OpenSSH server here. And again, we could have done that with sudo aptitude install OpenSSH server, but we're going to do it this time through the software. All right, so it'll install all the packages that it needs, all its configuration files, and set things up for whatever environment it happens to find. And among the things it's going to do is when we boot the machine next time around, it would start up this SSH daemon. Now, it does things in a particular order, of course. Right? There's no point in starting up a daemon to listen on the internet if you don't have your network up yet. So first you bring up the Ethernet cards, and then later on in the boot up process, it'll bring up the SSH daemon. And this guy listens on port 22. So to actually talk to a machine, you need more than just its internet address. Okay? So if you were Bilbo, you'd need 10.0.0.2. That's the, basically the apartment building, essentially, your street address for, say, an apartment building. But then you need to know which particular apartment door you're supposed to knock on. Right? That's the port numbers here. And there's 65,000 or so of these things, so quite a few. The really low-numbered ones are for system functions. And pretty much everywhere in the world, on every machine, Windows, Linux, or whatever, if you're running SSH, it's listening on port 22. Right? That's the default. Similarly, when we deliver mail, it always goes to port 25. Right? If two machines are trying to exchange mail, they talk to each other with the send mail daemon on port 25. If you go to a web server somewhere, almost certainly it's port number 80. You can set up a web server to listen on a different port number and have your own little private web server. But by default, it is port number 80. So SSH always listens at this particular apartment house door here, port 22. Okay? So what the SSH daemon does is listen for incoming requests from clients from elsewhere in the world. Okay. Now, normally, we don't let things come in here. Right? There's very few ports that are opened up by default. They try to keep this machine quite secure. But if we're installing the SSH daemon here to answer such requests, then we do open up port number 22. Right? Otherwise, anything that was destined to knock on that particular door never gets there. The bouncers at the front of the apartment building here keep people out unless they can go to an approved place. All right, so that's part of the configuration that's going to happen. So we'd have to do a similar thing if we install a web server, and we have to make sure we open up port 80. If we want mail to be delivered to these machines, we'd have to open up port 25 and so on. All that sort of stuff happens for you automatically when you install the appropriate patches. Now, that didn't used to be that way under Unix. You really did have to be a system administrator to be able to run this system effectively and just sort of know all of this stuff, have it accumulated across the board. Right? But nowadays, your grandmother can run a Linux system and it'll work pretty much just fine for her, because it is about this easy to set things up. It took a lot longer for them to make it so normal humans could run Unix systems than I expected here. Right? It seems to me they could have done this maybe in the 90s, but it didn't take off until maybe 10 or 15 years ago. Okay. Now again, we're going to play around here. We're going to put it back here, but you want to see how this stuff works. Well, we can ask it to remove the OpenSSH thing. Again, you got to get the # prompt, or it's just going to say you have permission to remove software on it. Right? So you can see how that comes out. It'd be similar to clicking the uninstall button if you were in the graphical user interface there. And you can try again then. So take it out and then put it back.